Okay, you've got your first graph. You've got three sets of data corresponding to three fan forces and the relative accelerations that came from those fan forces. You should have three lines of best fit to go with those three sets of data. I'm going to assume the worst case scenario, which is that your best fit lines look something like this: y equals 30.6 x squared. In this case, I have measured my distances in centimeters and not converted to meters. And I have also not used the form of y equals 1/2 times 61.2 x squared. That 1/2 will play a role here soon. But we can see that both of these are the same. If I turn either one off, it doesn't actually change anything. This green line is just the same either way. So we want to get from here to our second graph. Now to do that, well, first of all, I'm going to remind you, to get to your second graph, in your case, there should be a next button somewhere in the upper right-hand corner of your graph. And you should click that, you should get a new graph. You're going to be able to enter your next set of data in there. So I'm going to jump over here so I can write on this page. Now, I gave us an equation. Position equals 1/2 times the rate of acceleration times time squared. We talked about that a few times now. It relates where the fan cart is on its track to its rate of acceleration and when it is, from when it started. Now, if we have the situation of y equals 30.6 x squared, our position, or y, is taken care of. X squared, that's time squared, also taken care of. That leaves 30.6 being 1/2 of our rate of acceleration. So if 30.6 equals 1/2 of our acceleration, I'm going to abbreviate that. 30.6 is 1/2 of our acceleration, then 60, whoops, not 60, because 30.6 doubled is not 60, it's 61.2 must be our actual rate of acceleration. Now, remind you, this is 61.2 centimeters per second per second. We need to get to meters. To do that, we're going to move the decimal place over 2 times, and that's going to leave us with 0.612 meters per second per second. That is our rate of acceleration for the green line on this graph. Now, we're going to make a data table. I'm actually prepared over here. I'm going to slide over here. I'm going to make a data table with acceleration on the x side and force on the y side. My first acceleration here is 0.612. The force for this was fan force 1, which corresponds to 0.5 newtons. I'm going to do the same thing with y equals 92.4 x squared. If I double 92.4, I should get 184.8, right? 184.8. You can check that. Move the decimal place over 2. That leaves me with 1.848 meters per second squared. I will put that, my next point in the data table, 848. This was fan force 3, which corresponds to an actual force of 1.5 newtons. And then I've got my last equation, y equals 153x squared. I double 153, that's 306. And I move that decimal place over, I get 3.0 3.06 meters per second squared. I put that in my data table, 3.06 meters per second squared. Fan force 5 corresponded to an actual force of 2.5 newtons. So I'm going to take that and I'm going to make a graph. Here's my graph. You can see my data table here, 0.612, 1.848, 3.06. I got these 3 points on the graph here. Notice my x-axis is labeled rate of acceleration in meters per second, or meters per second squared. My y-axis is labeled force because that's what these two things correspond to. I found a best fit line, y equals 0.82x. Here we're going to move to my whiteboard system again. Now I've got an equation, y equals 0.82x. My y-axis is labeled force equals 0.82. My x-axis, remember that's my rate of acceleration. I'm in the way here. There it is. So I'm going to shorten that again to just, come on, pen, acceleration. So force equals 0.82 times acceleration. What is this equation? Well, what's 0.82? Remember, our fan cart here weighed 800 grams. This is our fan cart. And if I convert 800 grams to kilograms, I do the same decimal trick again, but 3 times this time. So I get 0.8 kilograms. That was the mass of the fan cart. That 0.8 kilograms looks strikingly like this 0.82 here. And it makes sense if this is now force equals, I'm going to say mass. I'm going to make this proposal times acceleration. What is that? What is that equation? You should be able to figure that out. Now, why is it 0.82, not 0.8? Well, if we have a little bit of drag, a little bit of air resistance, things don't work perfectly, and that thing was accelerating slightly slower than we'd actually expect it to, we would need the mass to look slightly higher than we'd expect it to in order to get the forces balanced. So if you end up with 0.8, that's awesome. If you end up with 0.82 or even 0.85, that's awesome. If your number here is dramatically different from the fan cart mass that you actually measured or that you looked at in the video, you might have done something wrong. So you might want to check that. Now, what I'd recommend you do is Google this. What is the equation force equals mass times acceleration? If you don't remember it. Find that out. This is going to be the essence of our conclusion that we're going to write. So this is how we make the second graph and what this second graph means. I hope this helps.